Okay, so first, let's talk about the parts of the ellipse, okay? Just so we can communicate, okay? What is this, what is this, what is that? So we have an ellipse, we call it like type 1, that looks like this, okay? So it's long in this direction, or we could have one that's long like that, okay? And we're freehanding, but just pretend they're perfect ovals, okay? The x-axis on this one is like this, and that's the x-axis on this one, okay? Now notice on the x-axis, this one is longer, okay, on this one. In this case, we call this the major axis, okay? In other words, it's the long axis, okay? Here's your y-axis. Here's your y-axis. Okay. On that picture or that scenario, that type 2 or whatever, this is the long, right? So this one's called the major axis. So the long side is what we call the major axis. And in common sense, what do you guys think we call this side? If this is the major, this would be the minor. And that's exactly what it is, minor axis. Okay, which is the short side. Okay, in this case, this one's the minor axis. Okay, so just learning the different parts so we can communicate. On the major axis, those two, I don't know how we could refer to them, but the proper name, the ends of the curves, they're called vertex, okay? Where it has the change of direction. So that's called the vertex. This is called the vertex. Okay. However, on the short side, or the minor axis, what color could we use here? In a different color. On this side and this side, okay. This is a new word, I think. I don't think we've used this word. What's the same word, but we call it co-vertex. That's a co-vertex, that's a co-vertex. And it's to distinguish the vertex from the long side and from the short side. That's all it means, okay? So same thing here. On the long side, that would be your regular vertex or vertice. On the short side, you would have your co-vertex. Please let me know, okay, if something doesn't make sense to you. Okay. Are we good so far? Okay. There's more parts, but if I put them on there, it gets too squished, so I'm going to scroll down, okay? So we have these two. Actually, let's jump to the formula, and then we'll add the other parts. So part 2. It's called the standard form. For an ellipse. So this is the main one, okay? This is the one that makes it do whatever you want it to do, makes it look however you want it to look, okay? Very similar, guys. For those of you that were here yesterday, very similar to the circle, okay? So if you got the circle, it's kind of the same thing. You still have this, okay? And just like yesterday, those that you were here, that's still your right and left movement of the center location, but opposite, okay, opposite, just like yesterday. And it's still plus. Now put the plus a little bit lower this time because we're actually going to have a fraction. Hello?
A question for you.
Yes, ma'am.
Can you unlock Elijah Cott's?
It should be. Just tell him to refresh it or restart it. It's off. I don't know why it's, yeah.
Okay,
If it doesn't restart it, that usually fixes it for sure. Yeah. Mm-hmm. Okay, and then y minus k squared. Okay. Now, if you weren't here, this is a big deal. If you were here, you learned this yesterday. But if you weren't here, this is a big deal. K is the up-down movement. That's the same as yesterday, as always. It has been, but it's opposite this time. Okay, a liar, like Alexis mentioned yesterday, right? Liar. It behaves the opposite. So up is negative, down is positive. Okay. Now the difference on this one yesterday was equal to what? You guys remember? R squared. Okay. This one's equal to 1. Okay. It's different. So slight differences. Okay. Okay. This. So right below this, let's add another one because I got to explain something to you. Let's have the major axis here, the minor axis here. Okay. So the difference with the ellipse is the radius, again, is not the same. This length, bless you, is not the same as that length, right? Obvious. So we have to differentiate between the two. So we call the major, the long one, the long radius, we call that A. Okay. Because we can't call it R because it's not the same no more. Okay, so notice the A in this case is with the x-axis, so we put it under the x, and it's squared. This is how it's different than the circle. Okay, that's why the formula is a little bit, very similar, a little bit different. The short axis, okay, that's this one, that's the y-axis, so it's going to go over here with the y. We call that one, what do you guys think of? This one's A, B. Math is a lot of common sense, right? It's common sense. B squared. Okay. And that's it. That's how we distinguish the long side from the short side. Okay. Now, what if we have the other oval, right? The other ellipse. Okay. How does the formula change? So here's the really important part. Okay, yesterday I emphasized the hard part about the circle is understanding the radius is squared. The hard part about this is understanding who's A, who's B. So A right here, let's go ahead and put that. Always on the major. Okay, so it's always the long one. A is always the long side. So in this case, A is the Y. It's not B this time because A is the long side. So the formula will slightly change, okay? The x h squared plus y, that's the same, and the 1 is the same because the center is still the same spot. What changed is the radius, right? So now my long side is with the y, so I have to put the A with the y, because that's the long one, right? And then on this one, the x is the short one, so B. So the B goes with the x. Does that make sense, guys? So A is with the long one, B is with the small one. Okay. One last thing to emphasize: always. So for ellipses, it's always equal to 1, and always plus in the middle. Okay, so you're never going to have minus in the middle. You're not going to have a 2 out there. It always has to be equal to 1. So those are our formulas. Okay. Any question you guys can think of? Okay, there's more, a little bit more to it, okay, but I don't want to put it all in one part, so let's go ahead and go to examples. There's one more part called the focus, but I'll introduce that here in a little bit. Let's do number 1. Let's say you had x squared plus y squared equals 1. If I left it like that, that's a circle with a radius of 1. Okay? But if I put these numbers on the bottom, now it's an ellipse. See the difference? Very similar, a little bit different. Okay? So the first thing, we're going to sketch this by hand. Okay, we'll use the decimals here in a little bit, but first by hand. I need to write it like the formula. So I need to write those numbers as squares. Okay? So 64 is really what number squared? 8. And then 25 is really 5 squared. Okay? So remember the big number, that's your long major axis. So that's your A. So A is 8 and B is 5. Okay, now check this out. How easy this is to sketch. Okay. Did we move the center anywhere No, it's still in the middle, right? We don't have a plus minus. So the center is still right here in the middle. But the radius on the major axis, so the big radius is the A, is 8. So 8 this way, 8 this way. This one's super easy because you're counting from the middle, so it's 0, right? So 8 this way. The small radius is 5, so 5 down, 5 up. And so there's your vertex, and here's your co-vertex. And if you connect those, there's your ellipse. Questions, guys? Easy peasy? Okay. Let me let you try one. And I want you to do it by hand so you get a good understanding, but then check, like this is what you would plug in decimals, just like that, and it'll graph it for you, okay? So you can start getting familiarized with decimals. But go ahead and try one by hand, and then check it with decimals. 5 squared 9 plus y plus 2 squared 36 equal 1, okay? So provide a sketch for this. Okay. Try to sketch it on paper first and then do it on decimals. So here we go, okay? It gets easier and easier as we go through. So first, this is the order you want to do. You want to do the middle first. So I'm moving right 5. What is that plus 2 moving?
Down.
Down, right? Because it's opposite. So that's where you start. So I go here. I go right 5, down 2. That's my middle. Okay, you want to start with the middle. Once you know the middle, the center, then you can do the radius, the axis, right? So this is really 3 squared, and that's really 6 squared. So A is 6, that's the long side, right? And then B is 3, that's the short side. Short radius, long radius. Okay, so from, now notice 6, okay, the A is with the Y. So that's where you're counting 6. So 1, 2, 3, 4, 5, 6. This is really rough sketch. Okay, 1, 2, 3, 4, 5, 6. I'm just trying to get right to those answers. Okay, and then 3 on the X. Yeah, because 3 is here with the X, right? So 1, 2, 3, 1, 2, 3. Okay, and there it is. Okay, be honest with me, just so I can read the room. How many of you have kind of that sketch pretty close? Okay. That's really good, okay? It's because it was really the second problem, and we're getting there. So I promise by the end you'll have it, okay? Any question right now, though, guys? Right now that you have. Okay, it gets easier and easier, I promise. By the way, this is the vertex. This is the co-vertex, okay? Just to remember what's what, okay? Okay, so now I need to introduce to you the focus.